So the question we get asked a lot, will we need lean skills in our increasingly automated factories? And I'll save you the suspense, spoiler alert, yes, and I'm about to tell you why. But actually I want to be balanced about this. I don't want to be all binary about manual is good, machine is bad, or vice versa. If you couple the fact that I get asked that question a lot with, we exhibited last year at the TMMX Awards in the Smart Expo in Liverpool. We were invited with 50 of the most innovative startups in the UK. Now, of those 50, 49 were to do with things, machines, sensors, stuff. One was to do with skills. This was the only one to do with skills, is ours. So there is a fundamental imbalance between machines, things, sensors, and data, and looking at skills. Got me thinking there are 3 points to what I want to talk about here. Automation, lean principles, and the capability of people, and the marriage of machines and people. Start with automation. This here is Roger E. Smith. Roger E. Smith was running GM back in the 80s, 90s. He placed a bet that he could create a lights-out manufacturing facility for GM. Spent billions, somewhere around 90 billion dollars, sorry. He ended up with robots painting each other, paint robots painting each other, and he ended up with windscreen robots smashing windscreens because he'd gone too far. He tried to over-automate. Now this is a principle that Elon Musk has referred to a couple of times. In the intervening time, we've got better at automation, but Elon Musk recently said humans are underrated. In fact, I saw today that he'd said setting up the production system, getting the people engaged is the tricky bit, not automating everything. I firmly believe that machines and people are complementary. Cobots can ease tough work. They're very good in hostile environments where it's difficult for people to work. They're also very good in process industries, high capex requirement, high volumes, some kind of security going into the future, especially where human contact or contamination can affect the integrity of the product, food, pharma, microchips, for example. Automation is okay, but when you try for lights-out manufacturing, too much automation, there are various drawbacks. Firstly, it isn't a silver bullet. Capital dollars are scarce. We know this. They're always scarce. There's never enough money. Automating too much is very inflexible. What you end up with is kit that is very high spec, but if you lose the work, if a new model comes out, you cannot then easily switch that capacity onto something else. You're essentially swapping one set of problems for another. So if you automate away from people too much, you're swapping the problems of managing people for the problems of managing things, breakdowns, the technical side of it, troubleshooting, etc. They need programming, they break, they need fixing, they need maintaining, and there are certain jobs that humans are just better at. Automotive, aerospace, some other industries, we are better at our fine motor skills. We can do it a lot better than a machine can. Even if you do automate heavily, you still need people. Now, I'm going to argue for a balance in a minute, but currently I'm arguing for why you still need to keep thinking about investing in your people. Somebody has to spec the kit. There he is, the man in the red. Somebody has to commission it. Somebody has to program it. Somebody has to maintain it. Somebody has to load it. Somebody has to unload it. Somebody has to change the machine over. Somebody has to respond to it when the andon goes off. Somebody has to act on that andon. Somebody has to interpret the data that comes out of sensors, etc. Somebody has to problem solve, and a number of people have to find Kaizen. We'll come back to that in a bit. If you're going to realize the benefit of a huge investment in CapEx, you have to be able to get the people to the same skill level to make the most of it. So, having said you shouldn't over-automate or go for lights out, automate where you should, not where you can. So the question is, where should you? When the trend in manufacturing is towards short product life cycles, it's towards mass customization, it's towards lots of variety, shorter production runs, you don't want to put very expensive kit in for a contract that might not last too long. Where should you automate? Well, we've always faced the same problems in manufacturing, and we always will. It's a balance of SQDCP. Safety, you want people to go in with the same fingers and toes they came with. You want them to, you want to make good parts, then you want to ship the good parts on time, and you want to do all that within cost to turn the profit you want. So in terms of where should you automate, it's got to be the primary places are the quality and the cost bit for productivity. They're the bits that really, really support automation. Here's a classic example. I'm going to go back in time and then forward in time. Type G loom in Japan. I was in Japan 2018. I was in the museum, Toyota Museum. I wanted to see the original Type G loom. Now, Sakichi Toyoda, back in the 1930s, he saw his mother weaving. Toyota was a weaving company before it was a manufacturing company. Now, Sakichi Toyoda saw his mother, whenever there was a thread break, he'd see her have to unpick the garment all the way through. He invented a tiny knocker here that whenever a thread broke, the press would stop, the weaving loom would stop. Now, that's the invention of automation, built-in quality, if you like, from error-proofing devices. That meant that you could separate man and machine. Rather than having 24 looms and 24 people, you could have 24 looms and less people because you didn't have to mind the machines. That is a good example of where an observation of a quality problem has led to an innovation, to investing in automation. But the interesting bit, and kudos here to the Lean Enterprise Institute, they put out a table a few years ago now in a great book called Creating Continuous Flow. This table is a really good guide to how and where you should automate. So along the top there, you can see the standard activities that happen in a factory where there's machines and people. You load the machine cycles, you unload the machine, and you transfer the part to the next machine or stage of the production. And they reckon there are 5 levels of automation. 1, 2, and 3 lower levels. 4 and 5 are the higher levels, and there's a great divide I'll explain in a minute. Level 1 is where you have somebody doing all of the stuff. It's just a manual factory. Level 2 is where you automate the cycle time, machine cycle. So somebody has to load, somebody has to unload, but the automated cycle, and then they've got to transfer it to the next machine. The problem with getting stuck at level 2 automation is that you tend to have to double handle parts. Here and here. To load and unload, you handle a part twice in any given nest of the machine, which is why a movement to level 3 automation is a good thing, because if you can automate the unload, which is the easier bit, then you get a productivity bonus. You can have less people running the same number of machines. Where the great divide comes in is level 4, and this is where you've got to tread very carefully. This is where I'm talking about caution to lights-off manufacture. The moment you try to automate the loading and automate the transfer in level 5. I said earlier, humans have a real advantage over machines because of our fine motor skills, and with a variety of products and short production runs, we can easily pick and locate in a nest. To train a robot and to get the precision you need repeatedly to do that is really expensive, really expensive. And once you try to automate at level 5 with the transfer of the part, you're into transfer conveyors or transfer lines, and there's another cost there. So the great divide here is the fact that you get a lot of cost and a lot of complexity once you go to 4 and 5, and your reliability drops to, they reckon, about 70%. Crossing this great divide is where, and I'm not saying don't automate, I'm not saying automate, I'm saying think about it. Crossing that divide is a bold thing to do, and you have to do it for very clear reasons. A smarter way of thinking about all of this, and Industry 4 in general, is Japanese thinking. I'm lucky I've been to Japan a number of times, and I've pinched their thinking because it's better than mine. They think of it as a numerator and a denominator. The world is, of course, moving towards Industry 4 stuff. We are better at automation now, and we should be capitalizing on this. UK has dropped to 9th in the world in manufacturing from 7th. There are strong benefits to it. We can enhance the work of people. There will be some displacement of jobs, but other jobs will be created. As interfaces become more intuitive, it becomes easier for blue-collar workers to do what university-trained people used to do. Step back and think about your Industry 4 strategy. The numerator is machines, and the aim is to improve the equipment work. Can we improve the way the machine works? The denominator is people. Can we improve the people's work? And the idea is if you focus on both, you're going to open up a big benefit, twice as much benefit as if you just focus on the machine. So Industry 4, your efforts should be on predicting problems, finding symptoms early with the right kind of sensoring and measurement. With people, eliminating low value-added work, stuff like going around and counting for the first hour of the day what stock you have. Reducing variation in standard work. The fact that I might have a £1 million line, and on the morning shift, our setter can change it over in 40 minutes. On the afternoon shift, we've got no standard, and it takes him 2 hours, and there's a heap of scrap. That kind of leveling up of skill. And then in the middle for both of them, the ability to visualize issues better and identify the next Kaizen. Now, I didn't invent that, but I like it, because it makes you step back and consider before you automate, or Industry 4 anything. Which takes us on to lean principles. So we've concluded that machines are good if they can work at scale. There are some industries where they're really useful, process, capital intensive, but they are expensive and they can be inflexible, particularly if volume goes up or volume goes down. Volume goes up, you've got to invest in another big increment of capacity. I was in a Lexus plant in Japan 3 years ago, just before COVID, and they are working hard to strip machines down into smaller modules so that they can replace small increments of capacity rather than whole lines or whole big increments. Not monoliths, small increments. Capital is always scarce, and yet lean principles never fail us, but I would say that. A few years ago, I wrote an article for Planet Lean. I do articles for the manufacturer and Planet Lean. Lean's gift is that it's a benefit anywhere. Anywhere there's a process to deliver value to an end customer, you can lean it. I've done lean in charities, I've done it in non-manufacturing places, I've done it in finance. The fact that you can do it anywhere and that in any kind of process leads us to, right, so what are the key considerations in terms of automation for processes that need it? This is any given factory making anything, making whatever. In any given market, all of the people competing in that market, they have the same quality requirements from the punters, from the customer. They've got the same cost pressures, set the price, the market sets it to make a profit, and they've got the same delivery requirements and lead time expectations in the market. They've all got access to the same pool of labor, to the same materials, and to the same machine suppliers and material suppliers. This slide is generally used by lean people like me to say, look, the difference is if we've all got access to the left-hand side and we've all got the same expectations, it's the way you do it that makes a difference. And we argue for standardized work. That's not the point I want to make here. The point I want to make here is that if we focus just on automation, we are only focusing on one of the 4 M's. There are still three other M's that have to be looked at. Somebody in the business, team leaders, engineers, supervisors, leading hands, have to manage the people, getting the material flowing in the right place, bits turning up at the right time, and they have to manage up issue and Kaizen the method. If you try to lights out manufacture, who's going to do that? How do you manage the 4 M's? However, making an argument now for IoT, let's come back to Kaizen. I like IoT as a way to see inside the machine, to find hidden trouble and find the next most valuable Kaizen. If you take anything away from this, take those 2 things. If I'm going to put any kind of sensoring in, create some data inputs that might overwhelm me, I've got to do it for 2 reasons, to find hidden trouble and find the next most valuable Kaizen. What do I mean by hidden trouble? There's a machine, there's hidden trouble inside the machine. It's guarded, you can't see it. If we use IoT and sensoring, then we can see the hidden trouble because the machine tells us, and then we can act on the Kaizen. This is Toyota's approach to this. Their approach is we want to enhance skill and use advanced tech to find the problem. So they are connecting data collection and problem identification, but they don't want the machine to solve its own problems. They want it to help us identify the problems. So in this case, let's say it's monitoring the temperature inside the machine. It can monitor, it can tell us when something drifts outside of a parameter. They can collect the data. It can take pictures that the human eye cannot. And yet, I like to think about fishing here. There's something about being trained by Japanese engineers where they always talk about fishing. Catch small fish, not big fish. They just keep going on about it. And so it becomes embedded. Fishing, insofar as I worry about how people are collecting data currently. The big push for data analytics is great. The data lake, yes, we want to fill it. We want to look at what data's there. But what I'm seeing is that manufacturers who are hard pressed for time anyway, they're getting overwhelmed by the data and they don't know where to look first. If you're going to fish successfully in a lake that has different fish, different problems metaphorically, you have to know what kind of fish you're after, where to cast your line. Do they like to stick to the bank? Are they in the middle? What kind of bait do I use? Where do I cast? How do I cast? What kind of float? My point being, if you're going to harness IoT to collect data, you're best off starting with a question. What is the problem I'm trying to solve? And then look at how to solve it. Not, where can I collect data? Because you'll overwhelm. You won't be able to deal with it. More to the point, as a little aside, I put this up whenever I can. don't fool yourself on Kaizen either. Kaizen, true Kaizen, if this is our current standard, whatever form it might be, improving from below your standard to where your standard should be is not Kaizen. It's returning you to normal. You're just getting back to normal. If you are improving your current standard, you are truly generating Kaizen. So any improvement you make, whether it's off data censoring, be clear on whether you should be relieved or celebrating, because not all Kaizen is Kaizen. Leads us on to capability of people. I went to the Make UK conference in February. Andrew Neil always does a keynote there, but he always tips up at the Make UK conference, and he gives a really good 40-minute summary of what's happening in the world. And he was talking about the era of cheap labour is over, and the fact that when the Berlin Wall came down, we had access to 350 million people. When China joined the WTO, it opened another billion people up to us. There are no more Chinas, was his point. There are no more sources of cheap labour coming into the world. Italy, Germany, Russia, certainly, even China has a demographic problem. We have a demographic problem. There is a gap between the aging, skilled people in our factory and the younger ones we're trying to entice. So on the one hand, I can make the argument here for more investment. We should be investing more. But on the other hand, I've also made the argument that you need people still to run factories. So yes, we should be investing more, but you cannot automate everything. You still have to invest in the capability of people. Which leads us to this word. Apologies for the Japanese. Actually, sorry, not sorry. I quite like it. Monozukuri wa hitozukuri, Japanese phrase. It means make good people to make good things. If you want to make good things, you've got to make good people. And they will then make good things. It's a variation on focus on the process. How can we use IoT in terms of capability? To increase skills, to level skills amongst people doing the same job who have different skill levels, or to transfer, to capture into libraries, digital libraries, the skills of people who are aging and are going to retire, and transfer it to people who are younger but haven't got the skill set. Let's pause a sec. I've argued why you shouldn't over-automate. I think I've said why some automation is good, and the great divide where you should draw a line or be careful. I've moved on to IoT and talked about the benefits of increasing capability in people. IoT, wearable tech, AR, VR, eye movement tracking, digital libraries, they can be really, really useful for all of these things in capturing knowledge and doing those three things in your business. I guess my clarion call is when you think about IoT and you think about Industry 4, please don't think about machines only. Think about people. Finally, the Toyota view. This is me in China. Next to me is a fellow called Katsuki Aoki. He's a professor in Japan who spends a lot of time ferreting around in Toyota and Lexus factories. I spend a lot of time talking to him, and that's my sensei in front, Muraoka-san. We were in a factory in China. I was talking to Aoki recently, and he introduced me to Toyota's current thinking. They have a core evolution strategy, and that strategy is a marriage of human skill with advanced technology. But they don't want advanced technology to replace the human. They want to marry the best parts of both. To do this, they developed something 7 years ago called highly skilled worker development. So far, 80 people have graduated, probably up to 100 now. 300 are going through it, and they've been running it for 5 years. They take people in their 30s in their factories, good skilled operators, and they upskill them hugely over the 5-year process because they've realized something. Their best associates, operators, are in their 60s now. They're not far off retirement. When they were learning the process, the production process, the technology, there was at least 50% less automation. So they could get in amongst the kit. They could understand how mechanically it worked. They're younger people, particularly engineers out of university. They understand the bells and whistles, the PLCs, the mechatronics side, but they've never actually seen the machine working in its infinite detail and struggle to troubleshoot because there are that many bells and whistles and extras added, they can't get to the guts of the machine to understand it. Particular problem that Toyota see in their younger generation, both in Japan and overseas group companies, is troubleshooting. There is a lack of ability to troubleshoot because they don't understand the technology. So they've created super skill lines. And super skill lines is where they take their sexy machines And then they strip them back right to basics, to completely manual machines, so that people, engineers and high-skilled operators can learn how at very, very grassroots they can make the part, make some better troubleshooters. I've started doing this with some of our clients, training setters and technicians. They have to draw the machine for me, draw the process and explain it to a child, because then you really understand it. The principle behind it is that if you have an unskilled programmer of a robot, you end up with an unskilled robot. And their view is that AI might help in the future in terms of learning cycles and deep learning, but you want skilled programmers to then transfer their knowledge to skilled robots. Their logic, improvement is based on the recognition of problems on the Gemba, the shop floor, by humans. They want to improve in a low-cost style and rely on shop floor Kaizen, Gemba Kaizen, not jump to introduce advanced technology. They know that too much advanced technology too soon ends you up where Roger Smith and GM were in Fremont.